Good morning, grade 10s. It's Friday morning. Hope you have a good weekend planned. We are going to do the third and final method of solving systems. So let's get down to it. Now, this I would recommend. We are on page 193 of the pre-dip book or 178 of the regular book. I would recommend probably not writing anything down for a little while. I'll tell you when you should start writing. Unless you want to write it all down, then go ahead. But really, you don't need to for a while. So as you can see here, I've got two equations. I've made one red, one blue. So I'm going to graph this. So 4x plus 3y equals 0. 3y equals negative 4x. Y equals negative 4/3 x. And then there's no y-intercept. So I'm just going to write plus 0, so it's in slope-intercept form. I'll do the same thing with the red one, or the blue one, sorry. 5x minus 3y equals 27. Negative 3y equals negative 5x plus 27. Y equals 5/3 x minus 9. Now, I've got two lines there, so I'm going to go ahead and graph them, like I always would. Put them on the graph. The red line goes through 0 and 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And there's my red line. I'm just going to sketch it on there real quickly. There we go. And my blue line goes through negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's got a slope of positive 5/3. 1, 2, 3, 4, 5. 1, 2, 3. Oh, look. They cross right there. So my solution is 3, negative 4. And of course I check that. 3 times 4 is 12. 3 times negative 4 is negative 12. 12 minus 12 is 0. 5 times 3 is 15. Negative minus 3 times negative 4 is negative 12. 15 minus 12 is 15 plus 12, which is 27, so I'm right. Now, watch what happens. Pick a number. You can just do this in your head. Any number you want. Everybody got a number? Okay. I'm going to use the number 4. Multiply both sides of the second equation, the blue equation, by 4. So I'm going to go ahead and keep using blue. So I had 5x minus 3y equals 27, which is the same. Multiply by 4. So now I have 20x minus 12y equals 108. Now, put that in slope-intercept form. Solve for y. And you get negative 12y equals negative 20x plus 108. Y equals negative 20 over negative 12x plus, minus 108 divided by 12 is 9. 20 over 12 is negative 5/3 x minus 9. Hey! What happened? We got the same line. So what does that tell us? If I multiply both sides of a linear equation, I get results in a new equation right there, but that new equation will have the same graph. All right, so let's do some more work with this. Here's my two equations, right? They're the same ones. Let's add them. So I'm going to add the equations. Red and blue makes purple. 4 plus 5 is 9x. 3 minus 3, hey, The y disappears. 9x equals 27. So x equals 3. Now if I put this on our graph up here, x equals 3, well that line goes right through there. Wait a minute, it gave me half of my solution. So what do we notice? If we eliminate one variable, we get half our solution. So what do you think would happen if we eliminated the x? Well, then we would get this line right through here and get the y part of our equation. Now, what happens if I subtract here? I'm not even going to do that. Oh yeah, sure, why not? 4 minus 5 is negative x. 3 minus 3 is 6y equals negative 27. If I solve for that, I'm going to get a third line. Remember, if I add or subtract two linear equations, that results in a new equation which still shares solutions. So, what does that mean? We could multiply the equation, which also means we could divide the equation. We can add the equations to eliminate one of the variables and get half our answer. We can subtract to do the same thing. As long as we do it to everything, we're going to end up with the same solution. So let's have a look at this. Here's a system. Give me one other equation that will have the same solution. Well, I could do this. Times 2. Times 2. And that would give me 6x plus 4y equals 36. That works. I could add them and get the same solution. I could subtract them. I could divide them. So just be aware. Now, on page 195, here is where you should start writing. Now, I'm going to tell a quick little story here. When I first started teaching math, I taught substitution first. And the kids are like, oh man, this is really, really hard. I don't get it. We practiced it for a day. And then the next day I taught elimination. And every kid said, oh, Mr. Myers, elimination is so much easier. Why didn't you teach us that first? So being the good teacher that I am, I listened to the kids. And the second year I was teaching, I taught elimination first. And the kids went, oh, this is so hard. And then I taught substitution. Oh my gosh, it's so easy. Why didn't you teach substitution first? So the third year I reversed it again. And of course, guess what the kids did? So there's no good way to do it. I just do it this way now. So I'm going to use 3 different colors as always because there's 3 different steps. And now again, you should be writing down. So I look at this equation, this system of equations, and I know I can add or subtract and have everything work out. So if I add these, I'm going to get 7x, and negative 5 plus 5 is 0. So that's going to disappear. So I've eliminated it. 7 and negative 9 plus 23 is 14. So that's the first thing. I've added or subtracted to get rid of one variable. Now remember, when you want to get rid of that variable, we are looking for ones with the same coefficient, which is the number out in front. If they're opposites, then you're adding. If they're the same, you're subtracting. Solve for that remaining variable. So, solve for x. Divide by 7, divide by 7. X equals 2. Easy peasy, right? Lastly, if x equals 2, then that x is 2 and that x is 2. We know them, so we no longer have two unknowns. So I can take that x and put it anywhere else I see an x. I could put it in the first one. 3 times 2 minus 5y equals negative 9. 6 minus 5y equals negative 9. Negative 5y equals negative 15. Y equals 3. That's if I put it in the first one. Now, look what happens if I put it in the second one. 4 times 2, because it's still an x, plus 5y equals 23. 8 plus 5y equals 23. 5y equals 15. Y equals 5. So now I have an x and a y. So my final answer is y equals 3. Duh, idiot head. 15 divided by 5 is 3. 2, 3. Now, Mr. Miles, did I do it right? Did I do it right? I don't know, kid. Did you? Check it. Well, what's 3 times 2? 6. What's 5 times 3? 15. 6 minus 15 is negative 9. It's right. What's 4 times 2? 8. What's 5 times 3? 15. 8 plus 15 equals 23. It's right. Everybody cool? Now, this is when you all sit at home, well, the 5 of you that watch these videos, and say, oh, so much easier. Should have taught this one first. All right, now let's have a look here. What's the problem here? We don't have a coefficient that's the same. But we remember we can multiply to change the coefficients, but it keeps the same line. So I have to get the coefficients the same. So what if I multiplied this top one by negative 3? What would I get? Well, I would get negative 3x plus 6y equals negative 21. Now, do I have the same coefficients but opposite signs? I do. So that means I can go ahead and do my eliminations. Remember, first thing I do is add or subtract to get rid of them. Well, if they're opposite, I'm going to add, aren't I? 3 plus negative 3 is 0x. 4 plus 6, 10y, equals 1 plus negative 21 is negative 20. So I've eliminated the x. Next, I solve for the remaining variable. Divide by 10, y equals negative 2. Now, what do? Everywhere I see a y, it's negative 2. So, x minus 2 times negative 2 equals 7. X plus 4 equals 7. X equals 3. Or, and you don't have to do both, I'm just showing you they both work, plug it in here. 3x plus 4 times negative 2 equals 1. 3x minus 8 equals 1. 3x equals 9. X equals 3. So my final answer is 3, negative 2. Mr. Mize, did I do it right? Check it. What is 3 minus 2 times negative 2 is negative 4. 3 minus 4 is 3 plus 4, which is 7. So we did it right. 3 times 3 is 9. Minus 8. 9 minus 8 is 1, so we did it right. Now, let's come to this one. What's the same? Nothing's the same. So, I'm going to go ahead. I'm going to multiply. I got to get two of these numbers the same. So it's almost like a common denominator, isn't it? I don't want to work with 11 because it's such a big number, so I'm going to work with the y's. What can I do to get 3 and 2 the same? Well, same thing I do with a common denominator. If I multiply that by 2, I'm going to get 4x minus 6y equals 40. And if I multiply that by 3, I'm going to get 33x plus 6y equals negative 3. And all of a sudden, there's my ones that are the same. Add them. 37x equals 37. Solve it. Divide both sides by 37. X equals 1. Then, guess what? I just put it in everywhere I see an x. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Negative 3y equals 18. Y equals negative 6. Or 11 times 1 plus 2y equals negative 1. 11 plus 2y equals negative 1. 2y equals negative 12. Y equals negative 6. So my final answer is 1, negative 6. And you check it. All right. That's it. Now, listen. Here is some elimination practice. Do them. 197. 197 is more elimination practice. And if you go back a page, you will find on page 192, there's a puzzle sheet that uses substitution. So you should do both of them. Okay? And on Monday, one more lesson. All right? We're not having a quiz this unit because there's no real need. And you guys have a good weekend. And remember, you should do, and I'm just going to finish the video with this, you should do the 2 puzzle sheets and the 2 textbook sheets. Okay? You have a good weekend. We'll see you later.